Deep in the mountains of Namyangju, Gyeonggi-do, about an hour east of Seoul, where the pine forests climb steep ridges and the air carries the clean sharpness of elevation, there is a farm that most people driving through this region would never notice. No large signs, no industrial buildings visible from the road. Just a winding path leading up into the trees, and somewhere above, the sound of tens of thousands of wings moving in the morning air. This is a family apiary, passed down through generations. And what happens here? Every harvest season is a process that blends traditions going back centuries with the practical demands of feeding a modern market that cannot get enough of what these bees produce. South Korea has a deeply rooted beekeeping culture that stretches back over 1,000 years. Historical records from the Goryeo dynasty period reference honey as both a food and a medicine, and the practice of maintaining hives in mountainous regions has long been considered one of the most respected forms of farming in Korean agricultural tradition. The mountains of Gyeonggi-do, the province surrounding Seoul, have been home to apiaries for generations, precisely because the terrain and vegetation create ideal conditions for bees to thrive. Diverse wildflowers, acacia groves, linden trees, and wild herbs cover the hillsides, giving bee colonies access to an extraordinary range of nectar sources that produce honey with a complexity of flavor rarely found in large, flat agricultural regions. What makes this particular farm worth paying attention to is that it is still family-operated at every stage of the process. The son, dressed in full beekeeping work clothes, handles the physical management of the hives. The father manages the broader operation. Every decision about when to harvest, how to treat the colonies, and how to process and package the final product is made by people who have spent their entire lives working with these bees. There are no outside contractors brought in for harvest season, no third-party processing facility down the road. Everything that happens between the hive and the jar takes place on this property, managed by the same hands that have been doing this work for decades. Before anything else can happen on harvest day, the bees need to be managed. A colony of honeybees in full summer production can contain anywhere from 50,000 to 80,000 individual bees, all of them instinctively protective of the honey they have spent weeks producing. Walking up to a hive and simply pulling it open without preparation is not an option anyone considers twice. The tool that makes this possible is smoke, and the way this family produces their smoke is one of the details that immediately sets a traditional Korean apiary apart from operations you might see elsewhere in the world. Rather than using pine needles, burlap, or commercial smoker fuel, this farm uses dried mugwort. Mugwort, known in Korean as suk, is a wild herb that grows across the Korean peninsula and has been used in traditional medicine, cooking, and agriculture for centuries. It is the same plant used in Korean rice cakes, in moxibustion therapy, and in countless other applications across East Asian culture. For beekeeping purposes, its value lies in the particular quality of smoke it produces. Mugwort smoke is cool, dense, and carries a distinctive herbal fragrance that research and generations of practical experience have shown to be exceptionally gentle on bees compared to harsher burning materials. The science behind why smoke works on bees is well established. When bees detect smoke, they interpret it as a signal of wildfire, triggering an ancient survival instinct. Worker bees immediately begin consuming honey in preparation for potentially abandoning the hive and relocating the colony. A bee that has gorged on honey is physiologically calmer and significantly less likely to sting, partly because the full abdomen makes it harder to bend and deploy the stinger, and partly because the instinct shifts from defense to preparation for flight. The smoke also masks the alarm pheromones that guard bees release when they sense a threat, preventing the chemical signal from spreading through the colony and triggering a mass defensive response. Using mugwort specifically adds another layer of consideration. The herbal compounds in mugwort smoke are harmless to the bees themselves, leaving no residue on the honeycomb or the honey that would affect quality or flavor. This matters enormously for a farm selling premium honey into a market where consumers increasingly scrutinize exactly what goes into their food and how it is produced. The choice of mugwort over synthetic or chemically treated smoking materials is not just tradition for its own sake. It is a deliberate, quality decision that has direct consequences for the purity of the final product. The smoker itself is a simple device that has changed very little in its basic design since the modern version was patented in the late 1800s. A bellows attached to a small firebox allows the beekeeper to direct puffs of smoke precisely where they are needed. A few puffs at the hive entrance, a few more directed under the lid before it is opened, and the colony response shifts within seconds. The sound of the hive changes, the pitch of the buzzing drops slightly. The bees that were clustered near the top of the frames begin moving downward. The colony is calm enough to work with. Opening a hive that is being managed properly and smoked correctly is a surprisingly quiet and controlled process. The lid comes off, and beneath it are the frames, vertical hanging structures made of a wooden border surrounding a sheet of foundation, which is usually thin beeswax or a plastic base embossed with the hexagonal cell pattern that bees will build upon. In a productive hive at peak summer harvest, these frames are covered with bees working continuously. Some are capping freshly cured honey with thin layers of fresh beeswax. Others are fanning the comb to continue evaporating moisture from nectar that is not yet fully cured. The activity is constant and purposeful in every direction you look. The sun moves through the yard methodically, working hive after hive with the unhurried efficiency that only comes from having done something thousands of times. Each hive box is opened, assessed, and worked in a sequence that minimizes disruption to the overall yard. Bees from one disturbed hive can agitate neighboring colonies if the process is rushed or careless. A calm beekeeper working at a steady pace with well-placed smoke keeps the entire yard manageable even when dozens of hives are being worked simultaneously. The frames selected for harvest are those where the honeycomb is fully capped. This is the critical quality indicator that every experienced beekeeper looks for before pulling a frame. When bees cap a cell of honey with beeswax, it means they have determined that the honey inside has been cured to the correct moisture level, typically below 20% water content. Honey harvested before it reaches this point carries too much water and is at serious risk of fermenting inside the jar. Fermented honey is unsellable and represents a significant loss, so the discipline of harvesting only fully capped frames is not optional on a professional operation. It is the foundation of consistent product quality. Partially capped frames, where some cells are sealed and others still open, are left in the hive for additional curing time. The bees will continue working them until every cell meets their standard, which happens to align precisely with the standard required for high-quality commercial honey. In this sense, the bees themselves are performing the quality control, and the beekeeper's job is simply to respect their judgment and not rush the process. Once the appropriate frames are identified, they are carefully lifted from the hive boxes and transferred. Each frame is heavy, a fully loaded honey frame weighing several pounds, and handling them requires a combination of physical care and deliberate movement to avoid crushing bees or damaging the delicate wax comb structure. Damaged comb means wasted honey and additional labor for the bees rebuilding what was broken. A skilled beekeeper handles frames with the same quiet attention you would give to something fragile and irreplaceable, because in a very real sense, that is exactly what it is. The frames are transferred to the honey harvesting area, where the next stage of the process begins. This transition from living hive to processing equipment is where traditional Korean apiary practice and modern food production requirements meet, and where the real transformation of raw comb honey into a finished product begins to take shape. The equipment waiting in the processing area is straightforward and purpose-built, and the process it enables is one that has been refined through years of practical experience on this particular farm, in this particular mountain landscape, producing honey that carries the specific character of everything growing on these hillsides. The harvest is just beginning. The frames are out of the hives now, stacked carefully in the processing area away from the yard. If you stand close enough, you can still hear the faint sound of bees moving on the surface of the comb, a few hitchhikers that came along during the transfer. A gentle brush clears most of them off, and they fly back toward the hive without any drama. The comb itself is extraordinary to look at up close. Thousands of perfect hexagonal cells packed side by side, each one sealed with a smooth layer of fresh white beeswax, the whole structure slightly warm to the touch from the heat of the colony it just came out of. Underneath that wax cap is the product of millions of flower visits, weeks of fanning and curing, and the collective effort of an entire living colony reduced to something that looks almost impossibly simple, golden, dense, and completely still. Before a single drop of that honey can be extracted, the wax caps have to come off. This stage is called uncapping, and the way it is done on this Korean mountain farm reflects the same practical precision that defines every other part of the operation. There are no expensive, automated uncapping machines here, no conveyor systems running frames through spinning chains or oscillating blades. This is a family farm, and the uncapping is done by hand, using a knife heated in hot water. The process is exactly as direct as it sounds. A container of hot water sits beside the uncapping station, and the knife blade is submerged and allowed to heat through before each pass. When the heated blade is drawn across the surface of the capped comb in a smooth, even motion, the wax caps slice away cleanly, without tearing the underlying cell structure. The heat is what makes this work. A cold knife drags and catches, pulling wax unevenly and risking damage to the comb itself. A properly heated blade glides through the cappings with almost no resistance, leaving the open cells beneath intact and ready to release their contents. The knife is returned to the hot water between passes to maintain the temperature needed for clean cutting. This rhythm, heat the knife, uncap a section, return the knife, reposition the frame, repeat, becomes automatic very quickly. An experienced hand can uncap a full frame in under 2 minutes while keeping the comb structure completely undamaged. The wax cappings that fall away during this process are collected in the uncapping tray below. They are not thrown away. Beeswax is a valuable secondary product with its own market. And on a well-run family apiary, every gram of cappings is saved, melted down, filtered, and either sold or repurposed. Beeswax from Korean apiaries is used in cosmetics, candles, wood finishing products, and traditional medicine preparations, making it a meaningful revenue stream alongside the honey itself. What is also worth noting about using hot water rather than an open flame or an electrically heated element is the safety and simplicity it represents. Hot water maintains a consistent temperature that is warm enough to melt wax cleanly, but not so hot that it scorches the comb or introduces any off flavor to the honey waiting just beneath the surface. It requires no electricity at the uncapping station, no specialized equipment, and no maintenance. A pot of hot water and a quality knife are tools available anywhere, and in the hands of someone who has performed this task thousands of times, they are entirely sufficient. Once a frame is fully uncapped on both sides, it is ready for the extractor. The honey harvesting machine used on this farm operates on a principle that has not fundamentally changed since it was first developed in the 1860s by the Austrian beekeeper Franz Hruschka, who discovered that comb could be spun to release honey through centrifugal force. The basic physics are simple and elegant. Frames loaded into the extractor drum are spun at speed, and the centrifugal force generated by the rotation flings the honey out of the open cells and against the inner walls of the drum. The honey flows down the walls and collects in the bottom of the drum, while the empty comb remains perfectly intact on the frame. This is one of the most important features of the extraction process on any quality apiary. Because the comb structure is preserved undamaged during centrifugal extraction, the empty frames can be returned directly to the hive boxes after harvest. The bees will clean every remaining trace of honey from the cells, repair any minor damage to the wax structure, and begin refilling the comb almost immediately. This saves the colony an enormous amount of energy and time. Building new wax comb from scratch requires bees to consume approximately 8 pounds of honey to produce a single pound of beeswax. Returning drawn comb to the hive eliminates that energy cost entirely and allows the colony to redirect its resources toward collecting more nectar and producing more honey rather than rebuilding infrastructure. The extractor used on this farm is a radial design, meaning the frames are arranged like spokes in a wheel radiating outward from the central axis. When the drum spins, both sides of every frame are exposed to centrifugal force simultaneously, releasing honey from both faces of the comb in a single spin cycle. This is more efficient than tangential extractors, which expose only one side of the frame at a time and require the frames to be manually flipped halfway through the extraction. On a farm managing a significant number of hives with a small family workforce, the time saved by radial extraction across an entire harvest season is substantial. The drum spins and the honey begins to appear on the inner walls almost immediately. It moves in slow golden sheets, thick and heavy, flowing down toward the collection point at the base of the drum. The color varies depending on which frames are being extracted. Honey from acacia blossoms, which is among the most prized varieties in Korean markets, is nearly water clear with just the faintest yellow tint. Honey from wildflower sources is deeper amber, sometimes with hints of reddish-brown depending on exactly which flowers the bees worked most heavily. Linden honey sits somewhere between the two, golden and slightly greenish in certain lights. The visual difference between these varieties in the extractor drum is immediately apparent to anyone who has spent time around honey production. And on a mountain farm with access to multiple diverse nectar sources, these distinctions carry real market value. When the extraction cycle is complete, a valve at the base of the drum is opened and the collected honey flows out. At this stage, the honey is raw and unprocessed, exactly as it came from the comb, and it contains particles that need to be removed before the honey is suitable for packaging. Tiny fragments of wax that broke free during uncapping, occasional bee parts, pollen grains, microscopic debris from the surface of the comb. None of this is harmful, but removing it is necessary both for visual clarity and for meeting food safety standards required for commercial sale. The first filtration stage uses a sieve, a mesh screen positioned below the extractor valve that the honey flows through as it exits the drum. The mesh catches the larger particles, wax fragments, and visible debris while allowing the honey and fine pollen to pass through freely. This is a gravity filtration, passive and unhurried, which suits raw honey production perfectly. Forcing honey through filtration under pressure generates heat and can damage the delicate enzymes and aromatic compounds that give high-quality honey its character. Letting it flow through the sieve at its own pace preserves everything worth preserving. After passing through the primary sieve, the honey is collected in a separation bucket, a large container where it will rest and settle before the next filtration stage. Even after passing through the mesh sieve, the honey still contains fine particles and air bubbles introduced during the spinning and flow process. Given time, these separate naturally. Fine wax particles and debris float upward and accumulate at the surface, where they can be skimmed away. Air bubbles rise and dissipate. The honey at the bottom of the settling container becomes progressively cleaner and clearer with each passing hour. The settling period also serves another important function on a mountain farm producing varietal honey. As the honey from different frames mixes in the settling container, the flavors of nectar from different flower sources begin to integrate. A pure acacia harvest that went straight from hive to jar would taste entirely of acacia. But mountain wildflower honey that has settled and blended carries a layered complexity, notes of different flowers weaving together into something that reflects the full landscape the bees worked across. This blending is not accidental on farms that produce wildflower varieties. It is part of what defines the product and distinguishes it from single-source varietals. The honey is settling now, slowly clarifying in the bucket. The wax cappings from the uncapping station have been collected and set aside. The empty frames are stacked and ready to go back to the hives. Outside, the bees are still flying, the mountain flowers are still blooming, and the process that turns all of that activity into something you can put in a jar and carry home is almost complete. The settling bucket has been sitting for several hours now. Walk up to it and look down through the surface, and you can already see the difference from what came out of the extractor drum earlier in the day. The honey has clarified noticeably. The foam that accumulated at the top, a mixture of fine wax particles, air bubbles, and microscopic debris, has separated cleanly from the honey beneath it. A wide flat spoon drawn across the surface removes that layer in a few passes, leaving honey underneath that catches the light differently than it did before. Deeper, cleaner, the color more uniform from edge to edge of the container. This skimming step is simple, but it matters more than it might appear to. The foam layer contains oxidized honey that has been exposed to air during the extraction and settling process, along with concentrated wax residue and particles that passed through the primary sieve. Removing it before the second filtration produces a cleaner baseline for the honey going into the final filter stage, reducing the load on the finer mesh and producing a better result with less effort. On a family farm where every step is done by hand and efficiency matters, small refinements like this add up across an entire harvest season into meaningful improvements in both product quality and processing time. The second filtration uses a finer mesh than the first sieve the honey passed through at the extractor. Where the primary sieve was designed to catch visible wax fragments and larger debris, this second filter targets the finer particles that made it through the first stage. Fine wax dust, microscopic comb fragments, and any remaining particulate matter are captured here while the honey flows through freely. The filtration is still gravity-driven, still passive, still unhurried. The honey moves at its own pace through the mesh and collects in the container below. It is worth being specific about what is not being removed during this filtration process on a traditional family apiary like this one. Pollen grains, which are too fine to be caught by the mesh screens used here, remain in the honey. This is intentional and significant. Pollen is one of the most nutritionally meaningful components of raw honey, containing proteins, amino acids, vitamins, and trace minerals that are completely absent from ultra-filtered commercial honey. Pollen is also the only reliable scientific tool for determining the geographic origin of honey. When researchers or food safety inspectors want to verify that a jar of honey actually came from the region and floral sources claimed on its label, they examine the pollen under a microscope. The species and proportions of pollen grains present create a fingerprint that can be matched to specific plants growing in specific regions. For a mountain farm in Namyangju producing honey that derives its value precisely from where and how it was made, retaining pollen in the finished product is not just a nutritional decision, it is a traceability decision. The pollen in this honey tells the story of these specific mountains, these specific flowers, this specific season. Removing it would strip out both the nutritional value and the provenance that justifies the premium price Korean consumers and export buyers are willing to pay for genuine mountain honey. Korean honey holds a particular place in the domestic food market that goes beyond simple sweetener status. Acacia honey, called acacia cool in Korean, is the most widely produced and consumed variety in the country, prized for its exceptionally mild flavor, light color, and slow crystallization rate that keeps it liquid and pourable for extended periods. The acacia trees that bloom across Korean hillsides every spring, typically in late April and early May, provide one of the most reliable and abundant nectar flows in the entire Korean beekeeping calendar. A strong colony positioned near acacia groves during peak bloom can fill multiple honey supers in the span of just a few weeks, making acacia season the most productive and financially important period of the year for most Korean beekeepers. Beyond acacia, the mountain honey produced from mixed wildflower sources across Gyeonggi-do carries its own distinct identity and commands strong interest from consumers seeking more complex flavors. The diversity of flowering plants on these mountain slopes, wild asters, clover, linden, goldenrod, bramble, and dozens of other species blooming in succession from spring through autumn, means that wildflower honey from this region changes character across the season. Early season honey tastes different from midsummer honey, which tastes different again from what the bees produce in late summer as different plant species come into and out of bloom. Experienced Korean honey consumers recognize and seek out these seasonal distinctions in ways that parallel how wine drinkers think about vintage variation. With the second filtration complete and the honey now sitting in the clean collection container below the final filter, the preparation of packaging materials begins. The containers used for packaging on this farm are prepared carefully before a single drop of honey goes into them. Cleanliness at this stage is non-negotiable. Any contamination introduced through the packaging container, residual moisture, dust, previous food residue, or microbial contamination can compromise honey that has been processed perfectly up to this point. Containers are inspected, cleaned, and arranged at the packaging station before filling begins. The honey is transferred from the settling and filtration container into the packaging containers through a bottling gate, a valve at the base of the container that allows controlled flow into each jar or bottle. Filling is done carefully to avoid introducing air bubbles into the finished product, which would create foam at the surface of the packaged honey and affect its visual presentation. A jar of honey with visible foam or air bubbles signals to a Korean consumer who tends to have high expectations for honey quality and presentation that something in the process was rushed or careless. On a farm where reputation is built jar by jar and customer by customer over many years, that kind of detail receives serious attention. The volume filled into each container is monitored closely. Overfilling wastes product that has taken enormous effort to produce. Underfilling is a food labeling compliance issue and damages consumer trust. On a small family operation, this monitoring is done by eye and by experience rather than by automated sensors, which makes the skill of the person doing the filling a genuine quality variable. It is one of the many places in the process where years of accumulated experience on this specific farm produces results that cannot simply be replicated by someone running the same equipment for the first time. Once filled, the containers are sealed and moved to the labeling stage. The product information placed on Korean honey packaging goes beyond what many international consumers might expect to see. Korean food labeling regulations for honey require clear identification of the floral source, the region of production, the harvest period, the processing method, and whether the honey is domestic or imported. For a farm selling directly to consumers and through local markets, the label is also a communication tool that tells the story of where this honey came from and why it is worth what it costs. Some family apiaries in Korea include the specific mountain name, the altitude of the apiary, and even the family name on their packaging as markers of provenance and personal accountability for the product inside. The quality of Korean domestic honey and its price premium over imported honey has become an increasingly important topic in the Korean food market over the past 2 decades. Imported honey, primarily from China and other Asian-producing nations, is significantly cheaper than domestically produced Korean honey and has captured substantial market share in the commercial food manufacturing sector. But among Korean consumers buying honey for direct household use, domestic mountain honey from identifiable regional sources commands strong loyalty and premium pricing that reflects genuine quality differences, as well as cultural preference for locally produced food. The Korean government has supported domestic beekeeping through various programs administered by the Ministry of Agriculture, Food and Rural Affairs and the Rural Development Administration, including research into bee health, disease management, varietal honey development, and marketing support for domestic producers. These programs recognize that Korean beekeeping is not just an agricultural industry, but a cultural practice with deep historical roots that contributes to rural livelihoods, pollination services for Korean agriculture, and the preservation of traditional food knowledge. Back on the farm in the mountains above Namyangju, the last jars of the day's harvest are being sealed and set aside. The frames that held this morning's honey are already back in the hive boxes, and the bees are moving across them, cleaning out every remaining trace of honey and beginning the work of refilling. The smoker has gone cold. The hot water from the uncapping station has been emptied and cleaned. The extractors and filters and settling containers have been washed and stored. The mountain is quiet now except for the sound of bees still flying in the late afternoon light, working the flowers on the hillside the same way they have been working them all day, the same way their predecessors worked this same hillside for as long as anyone in this family can remember. What ends up in the jar is more than honey. It is the specific character of these mountains, this altitude, this mix of flowering plants, this season, and this family's accumulated knowledge of how to work with the bees that live here. That combination cannot be manufactured at scale or replicated in a laboratory. It can only be produced the way it has always been produced, one frame at a time, one harvest at a time, by people who know these hives and these mountains well enough to read them correctly. That is what makes it worth seeking out.